Our planet Earth is a tiny oasis of life in the vastness of space. Floating in the cosmic ocean, it is a unique haven where life has flourished for billions of years. From the microscopic organisms in the deepest oceans to the towering trees in dense forests, Earth is teeming with life. This delicate balance of life is sustained by a myriad of factors, but none as crucial as our star, the Sun. But Earth's fate is not its own. It is intricately woven into the fabric of the cosmos, and more specifically, it is tied to the destiny of the Sun. The Sun's influence extends far beyond providing light and warmth. It shapes the very conditions that make life possible on our planet. It is inextricably linked to the life cycle of our star, the Sun. The Sun, a massive sphere of hydrogen and helium, undergoes nuclear fusion at its core, converting hydrogen into helium and releasing immense amounts of energy. This energy radiates outward, reaching Earth and driving the processes that sustain life. The Sun is a giant ball of burning gas, a nuclear furnace that has warmed and lit our world for billions of years. Its surface is a roiling sea of plasma with temperatures soaring to millions of degrees. Solar flares and sunspots are just a few of the dynamic phenomena that occur on the Sun's surface, influencing space weather and, in turn, life on Earth. Its gravity holds the Earth in orbit, dictating our seasons and the rhythm of life itself. The tilt of Earth's axis and its elliptical orbit around the Sun result in the changing seasons, which have profound effects on ecosystems and human activities. From the blooming of flowers in spring to the harvests of autumn, the Sun's influence is omnipresent. But the Sun is not eternal, it is a star. And like all stars, it has a finite lifespan. Over the course of billions of years, the Sun will undergo significant changes, eventually exhausting its nuclear fuel. This will lead to dramatic transformations that will have profound implications for our planet. Like all stars, it has a lifespan. Stars are born, they live, and they die. The Sun is currently in its main sequence phase, where it has been for about 4.6 billion years. However, this phase will not last forever. As the Sun ages, it will expand into a red giant, engulfing the inner planets, including Earth, before shedding its outer layers and leaving behind a dense core known as a white dwarf. Understanding this lifespan and how it will unfold is key to understanding the ultimate fate of our own planet. Scientists study the Sun using advanced telescopes and space missions, gathering data to predict its future behavior. By unraveling the mysteries of our star, we gain insights into the long-term prospects for life on Earth and the potential for humanity to adapt and thrive in an ever-changing universe. Right now, the Sun is in a stable phase of its life known as the main sequence. This is a period in a star's life cycle where it spends the majority of its existence. During this phase, the Sun maintains a delicate balance between the gravitational forces pulling inward and the pressure from nuclear fusion pushing outward. This equilibrium allows the Sun to shine steadily and provide a consistent source of energy to our solar system. This phase has lasted for about 4.6 billion years. Throughout this time, the Sun has been a constant presence in the sky, influencing the development of life on Earth. Its light and warmth have been crucial for the evolution of plants and animals, shaping the environment and ecosystems we see today. During this time, the Sun fuses hydrogen into helium in its core, releasing a tremendous amount of energy. This process, known as nuclear fusion, is what powers the Sun and produces the light and heat that reach Earth. The fusion of hydrogen atoms into helium generates an immense amount of energy, which radiates outward from the core to the surface and then into space. This energy is what we see as sunlight. Sunlight is essential for life on Earth, driving photosynthesis in plants, which in turn produces oxygen and forms the base of the food chain. The Sun's energy also influences weather patterns and climate, playing a key role in the Earth's natural processes. The Sun's output is remarkably consistent, providing a stable environment for life to evolve on Earth. This stability has allowed complex life forms to develop and thrive over millions of years. The consistent energy output from the Sun ensures that the Earth's temperature remains within a range that supports life, making our planet a unique haven in the vastness of space. But this stability won't last forever. The Sun is slowly but surely using up its hydrogen fuel. As it does so, changes will occur that will eventually lead to the end of the main sequence phase. The Sun will undergo transformations that will have profound effects on the solar system. The Sun's hydrogen fuel is finite. As the hydrogen in the core is depleted, the core will contract and heat up, causing the outer layers to expand. This will mark the beginning of the Sun's transition into the next phase of its life cycle. As it continues to burn, the Sun's core slowly contracts and heats up. This increase in temperature and pressure will eventually lead to the fusion of helium and other heavier elements, causing the Sun to expand into a red giant. This transformation will dramatically alter the solar system, potentially engulfing the inner planets, including Earth, and bringing an end to the stable environment we currently enjoy. In about 5 billion years, the Sun will reach a critical point. It will exhaust the hydrogen fuel in its core. When this happens, the Sun will begin to die. It won't go quietly. The Sun will enter a new phase of its life cycle, transforming into a red giant star. This transformation will have dramatic consequences for Earth. As the Sun burns out of hydrogen, it will undergo a dramatic transformation. This process, known as stellar evolution, is a natural part of a star's life cycle. Over billions of years, the Sun has been converting hydrogen into helium through nuclear fusion, providing the energy that sustains life on Earth. However, this supply of hydrogen is finite. Once the hydrogen in the Sun's core is exhausted, it will start fusing helium in its core. This marks the beginning of the end for our Sun as we know it. The core will contract and heat up, while the outer layers expand. This will cause the Sun to expand dramatically, transforming into a red giant. The Sun's outer layers will swell outward, reaching far beyond its current size. It will swell to an enormous size, becoming hundreds of times larger than it is today. The once familiar Sun will become an immense fiery giant. In this expanded state, the Sun will engulf the orbits of Mercury and Venus. These planets will be consumed by the Sun's outer layers, their surfaces scorched and vaporized. Earth's fate is less certain. While some models suggest that Earth might escape being engulfed, the proximity to the red giant Sun will still have catastrophic effects. Some models predict that the Sun will expand beyond Earth's orbit, incinerating our planet completely. If this happens, Earth will be reduced to a charred, lifeless rock. Even if Earth survives being engulfed, the intense heat and radiation from the red giant Sun will have devastating consequences. The increased solar radiation will cause temperatures to soar. Oceans will boil away, leaving behind dry, barren seabeds. The loss of water will make life as we know it impossible. The atmosphere will be stripped away, exposing the surface to the harsh vacuum of space. Without an atmosphere, Earth will lose its protective shield against harmful solar and cosmic radiation, and the surface will melt into a molten wasteland. The once vibrant and life-sustaining planet will be reduced to a scorched, uninhabitable landscape, a stark reminder of the inevitable fate that awaits all stars and their planets. Section 5. A Glimmer of Hope. Despite this bleak outlook, there is a glimmer of hope. Some scientists believe that Earth might be pushed outwards into a wider orbit as the Sun expands. This could potentially allow Earth to escape complete destruction. However, even if Earth survives the initial expansion, it will be a very different planet. The intense heat from the red giant Sun will likely strip away Earth's atmosphere and boil away its oceans, leaving it a barren, lifeless rock. Section 6. Beyond the red giant, a stellar corpse. The red giant phase won't last forever either. Eventually, the Sun will exhaust all of its nuclear fuel. The outer layers of the red giant will be expelled into space, creating a beautiful but short-lived cosmic spectacle known as a planetary nebula. At the center of this nebula will lie the Sun's remnant core, a dense, hot object known as a white dwarf. Section 7. Earth's uncertain future. The white dwarf Sun will be much smaller and fainter than its former self. It will emit little heat or light. Any remnants of Earth, scorched and lifeless, will continue to orbit this stellar corpse. The once vibrant planet teeming with life will be a desolate relic of a bygone era. Section 8. A cosmic perspective. The Sun's life cycle is a reminder of the vastness of cosmic timescales and the ever-changing nature of the universe. It also underscores the preciousness of life on Earth. We live in a privileged time during a stable period of our star's life. It is our responsibility to cherish this time and to protect our planet for as long as possible. Section 9. Conclusion: a story of change. The story of the Sun and Earth is a story of change. It's a story of creation, evolution, and eventual destruction. While the ultimate fate of our planet remains uncertain, one thing is clear. The Sun's life cycle will have a profound impact on Earth's future. Understanding this relationship helps us appreciate the fragility of our existence and the importance of cherishing our pale blue dot while we can.